Finally tonight in the future of everything. I don't know about you, but I spent the weekend refreshing for updates on our favorite interstellar visitor, that comet or question mark 3I Atlas. It is up to a little bit more strangeness. Now, last week we told you that 3I Atlas was getting way brighter, way bluer as it got close to the sun. Well, now...
For weeks, astronomers around the world have been quietly tracking a single object moving through our solar system at extraordinary speed. Its name is 3I/Atlas. Only the third confirmed interstellar visitor ever observed. But this time, something is different. This object isn't just passing through, it's forcing scientists to confront the question everyone has been asking since the moment it was discovered. What exactly are these interstellar visitors? And what do they reveal about the galaxy beyond our sun? New data has finally brought clarity, and the answer is more fascinating than anyone expected. If you enjoy calm, science-based explanations of real discoveries unfolding in space, make sure to subscribe because this story is one of the most important cosmic events of our time. The question everyone was asking. From the beginning, 3I/Atlas triggered a sense of global curiosity. It wasn't fear, and it wasn't science fiction. It was something deeper, uncertainty. Humanity has only recently developed the technology to even notice interstellar objects passing through our solar system. For centuries, we assumed our solar neighborhood was isolated. But objects like this prove that space is not sealed. Material moves between stars, debris from other systems crosses into ours. The question everyone asked was simple. Is this object ordinary cosmic debris, or is it something fundamentally different from anything we've seen before? What scientists finally confirmed. The latest observations have confirmed what astronomers were hoping to determine early on. 3I/Atlas is natural, but extraordinary. Its trajectory is unmistakably hyperbolic, meaning it is not bound to the sun and will never return. Its speed is far beyond typical solar system objects, confirming it originated from deep interstellar space. Spectral readings suggest a complex mixture of rocky material and volatile compounds, unlike the familiar comets of our own system. In other words, 3I/Atlas is not an anomaly because it breaks physics. It's an anomaly because it expands physics, showing how diverse planetary debris can be beyond our own star. Why this object matters, more than the last ones. Oumuamua was strange because it lacked a tail and behaved unexpectedly. Borisov was remarkable because it looked like a more classical comet. But 3I/Atlas may be the most valuable interstellar visitor yet, because it sits between categories. It carries both comet-like chemistry and asteroid-like stability. Its brightness variations suggest an irregular structure, but its motion remains unusually consistent. Each interstellar visitor has been different, and that is the point. These objects are not rare exceptions. They are samples of other solar systems, each one shaped by a different star, a different environment, and a different history. The answer it gave about our galaxy. The deeper meaning of 3I/Atlas is what it reveals about the Milky Way itself. For decades, scientists assumed interstellar space was mostly empty, with only occasional wandering bodies. But the detection of 3 interstellar objects in such a short time suggests something bigger. Our galaxy may be filled with trillions of rogue fragments, planetesimals ejected during planetary formation, drifting endlessly between stars. 3I/Atlas answers the question by proving that interstellar visitors are not impossible accidents. They are part of the galaxy's natural ecosystem. Star systems are not closed worlds. They exchange material across cosmic distances. What we learned about planet formation. Everywhere. Every planet forms in chaos. Young star systems are violent, unstable places. Giant planets migrate. Orbits collide. Objects are flung outward at extreme velocities. 3I/Atlas is likely one of those survivors, an ancient fragment thrown from its home system billions of years ago. That means studying it is like studying the early stages of another solar system without ever leaving Earth. Its composition, structure, and trajectory refine our understanding of how planets form everywhere, not just around our sun. It is a physical reminder that our own solar system's history is not unique. Why this changes the future of astronomy. 3I/Atlas represents the beginning of a new era. Until recently, interstellar objects were theoretical. Now they are real, and future telescopes will detect them earlier, track them longer, and perhaps one day intercept them directly. Scientists are already discussing missions designed to launch rapidly toward the next interstellar visitor, because each one is a free sample from another star system, delivered naturally across the galaxy. The question is no longer, do these objects exist? The question now is, How many are out there, and what else will they teach us? What makes the data so unusual? Even though scientists now agree that 3I/Atlas is a natural interstellar object, the data it produces remains deeply unusual. Interstellar visitors do not behave exactly like the comets and asteroids that formed around our Sun. Their surfaces have been exposed to millions of years of radiation, extreme cold, and collisions with microscopic dust grains moving at enormous speeds. That long journey changes them. It hardens their outer layers, alters their chemistry, and sometimes seals volatile material beneath crusts that only begin to crack open once they approach a new star. In the case of 3I/Atlas, subtle infrared fluctuations and unexpected brightness patterns suggest the surface is not simply rock or ice, but something far more complex, an ancient object shaped under conditions humanity has never directly observed. Why interstellar objects are cosmic time capsules? The true importance of 3I/Atlas lies in what it represents. Not just a rock passing by, but a fragment of another planetary system. Everything in our solar system shares a common origin. The asteroids, comets, planets and moons all formed from the same primordial disk around the Sun 4.6 billion years ago. But 3I/Atlas did not. It formed elsewhere, around a different star, perhaps billions of years before Earth even existed. That makes it a time capsule. Its composition preserves information about another region of the galaxy, another chemistry, another history of planet formation. Studying 3I/Atlas is like holding a sample from another solar system without having to send a spacecraft across light years of distance. What it reveals about planetary chaos. Interstellar objects exist because planetary systems are not orderly. In the early stages of formation, gravity creates chaos. Giant planets migrate inward and outward. Smaller bodies collide violently or get slingshotted away. Many young systems eject enormous amounts of debris into deep space. 3I/Atlas is likely one of those fragments, thrown out during a distant star system's violent youth, condemned to wander the galaxy alone for millions or billions of years. That means interstellar objects are not rare accidents. They are natural byproducts of planet formation itself, and their existence tells us that every star system may be constantly shedding material into interstellar space. Why scientists are racing against time. Unlike asteroids bound to the Sun, interstellar objects do not stay. Their trajectories are hyperbolic. They pass through once and then vanish forever into the darkness between stars. The observation window is short, weeks or months, not years. That is why telescopes around the world immediately focus on objects like 3I/Atlas. Every hour matters. Researchers measure its rotation, brightness, spectrum, and thermal behavior as quickly as possible, because once it fades beyond detection, there will never be another chance. This urgency is why interstellar discoveries generate such intense scientific attention, even if the public barely notices. What this means for future missions. 3I/Atlas is also reshaping conversations about the future of space exploration. Scientists have already begun designing concepts for rapid response missions, spacecraft that could launch quickly toward the next interstellar visitor. Imagine intercepting an object like this up close, sampling material formed around another star. Such a mission would be one of the most profound scientific achievements in history. While current technology makes interception extremely difficult, every new interstellar detection pushes agencies closer to considering it. The next visitor may be spotted earlier. The one after that may stay observable longer. Eventually, humanity may not just watch these objects. We may reach them. The real answer 3I/Atlas provided. So what question did 3I/Atlas truly answer? It answered the question of isolation. For centuries, humanity viewed the solar system as a closed neighborhood, but interstellar visitors prove that it is part of a larger galactic environment where matter moves freely between stars. Planetary systems exchange debris. Ancient fragments drift endlessly through space, and occasionally, one of them crosses our path, offering a glimpse into worlds we will never see directly. 3I/Atlas reminds us that the galaxy is not empty. It is dynamic, interconnected, and full of travelers. Outro. 3I/Atlas is not a threat, and not a science fiction mystery. It is something far more real, a natural visitor from another star system, carrying clues about planetary worlds beyond our reach. And in answering the question everyone was asking, it has shown us that our solar system is not isolated. It is part of a much larger, living galaxy, filled with wandering fragments of distant histories. If you enjoyed this calm, science-based exploration of one of the most extraordinary discoveries in modern astronomy, make sure to subscribe and turn on notifications. More interstellar visitors will come, and when they do, we'll be here to understand what they mean. Thanks for watching, stay curious, and I'll see you in the next video.